Hi everyone, in this video we're going to talk about recursion. So if you've taken other programming classes, you've probably run into recursion before, and maybe you love it and you think it's really cool, maybe you think it's intimidating and hard to understand, or maybe you're somewhere in between. All of those are fine. I think it's just good to keep trying. If you're not understanding it, just keep seeing it again and again, and hopefully that will help clarify. So the basic idea is that when a function calls itself, that is a recursive function. And so we can use recursion to write down solutions to problems, in particular that have one or more simple cases with straightforward solutions. We'll see an example of that in a minute. And then also have other cases which can be redefined in terms of problems that get closer and closer to the simple cases. And so the basic pseudocode that we will follow for our recursive solutions that we develop is right here. Let's see if I can make this any bigger. So if basically what we do is, what our recursive function will do is it'll test, is my input one of my simple cases? If it is, write down the solution, or return the solution. Otherwise, I need to redefine the problem and apply my recursive function to that smaller version of the problem. And a lot of times we call these simple cases the base case, and any other case a recursive case. The book doesn't use this notation, but I do, so you might hear me say it. But we could call it a simple case, we could call it a base case, either way. So in order to start understanding recursion, let's look at an example where we would like to compute n factorial using recursion. So what is n factorial? Well, for example, I guess we define, so factorial is a problem that's very naturally recursive because we actually sort of need to define it recursively. So 0 factorial is defined to be 1. So that's sort of our base case, right? This is just, as mathematicians or computer scientists, we just define 0 factorial to be 1, and then n factorial is just going to be n times n minus 1 times n minus 2 dot dot dot, I guess we'd say times dot 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 times, and then eventually we get to 0, or to, not to 0, to 1. So if it was 5, say, we would have 5 times 4 times 3 times 2 times 1. And I believe this is 120. Maybe we could just check ourselves. 5 times 4 is 20, and 6 times 2 is 6, and 20 times 6 is 120. So that's great. So I can think of it this way, but I could also think of, what is 5 factorial? Well, it is 5 times 4 factorial, right? Like, that's what, if 5 factorial is 5 times 4 times 3 times 2 times 1, then 4 factorial is 4 times 3 times 2 times 1. And let's see, what is 4 factorial? Well, it's 4 times 3 times 2 times 1. What is 3 factorial? It's 3 times 2 times 1. What is 2 factorial? It is 2 times 1. And Then what is 1 factorial? It's just 1. And I could even say, oops, I started writing these wrong. So 4 up here, we want 4 times 3 factorial, but now we have to define 3 factorial. So 3 factorial is 3 times 2 factorial, and 2 factorial is 2 times 1 factorial, and 1 factorial is 1 times 0 factorial, and then this 0 factorial is just defined to be 1. And so now we could think about going back up this chain, and okay, so I know what 0 factorial is, so I can substitute it in here. Yeah. So I substitute in 1 for 0 factorial, and now I know what 1 factorial is, right? So then it's just 1. So now I can substitute 1 for 2 factorial, right? Or for 1 factorial, excuse me. But now I know what 2 factorial is, because it's just 2 times 1. So then I go back up and I substitute 2 for 2 factorial. And now I know what 3 factorial is, because it's just 3 times 2, which is 6. So now I can substitute 6 for 3 factorial. Now I come up here. So now I know what 4 factorial is, because it's 4 times 6 would be 24. So I can substitute 24 for 4 factorial. And then here I'd have to multiply 24 times 5. I guess so. Now 5 factorial equals, but 24 times 5 gives me 120. So that would be the recursive way of computing 5 factorial. And the nice thing is it's very easy to write down. So if I wanted to define my recursive factorial function here, so I like to think of first what is the base case, and what should happen, and then what is the recursive case and what should happen. So for factorial, we've said that by definition the base case is when n is 0. So n is our input here. So if n is 0, and let's say that I'm going to need to return something, so let's just define a integer variable for ourselves called answer, and we know that we're going to have to return that. So okay, cool. So now we've got something that we can assign to. So in the base case, we saw that by definition 0 factorial is 1, and so we should return, we should set answer equal to 1. And so if I assume that my input is always greater than or equal to 0, then any other case is the recursive case, right? I don't actually need to do a check here, I can just do an else. So this is any other number. So suppose n could come in to me as 3. If I got a 3, what should I do? So e.g. n equals 3. Then need to compute then 3 factorial equals, let's look back up here. What is 3 factorial? It's 3 times 2 factorial. So I say 3 times 2 factorial. So how do I write that in my C code here? I would say my answer is n times factorial of n minus 1. Okay, and now to check that our recursive function is working here, let's just get an input from the user and compute its factorial. So I'm going to declare an integer num, and I'm going to I'll ask the user for a number, enter an integer greater than or equal to 0. And then I'll get that integer from my user, passing in the address of num. And then I'm going to say factorial is, and I'll print out whatever I get back from factorial of num. And let's see what we get here. I think I have a factorial, yeah. Okay, so we saw 5 should give us 120. If we do 6, it should be 120 times 6, right? So 120 times 6 would be 600 plus 120 would be 720. 720. So that is looking pretty good. So that is our first example of writing a recursive function. One thing you might notice is that we could have done this with the for loop, right? I could have said I could have used a for loop to do this sort of method up here, right here. And it is true that any recursive solution could actually be implemented as an iterative solution. The reverse is also true. Any iterative solution could be implemented recursively. And so as a programmer, you will just need to decide when to use recursion and when to use iteration.